Good morning, everyone. Good day, morning, afternoon, evening to all of you. I am Gilberto Câmara. I'm Secretary Director for the Group of Earth Observations, and it is my pleasure to welcome you back to the second day of the GEO-INPE webinar on Brazil's forest monitoring system. It's a great pleasure to have you here and welcome to the discussion. It is also my great pleasure to introduce today's moderator, Dr. Thelma Krug. Dr. Thelma Krug is a very, very senior person. She is being Director for Earth Observation at the National Institute of Space Research. She is currently Vice Chair of the IPCC for the 6th cycle and have been co-chair of the IPCC Task Force on the National Greenhouse Gases Inventory. And she has had innumerous important positions, including at the Ministry of the Environment. She was Secretary for Climate Change, and she is extremely well known in the UNFCCC because she has represented Brazil in the negotiations, and she's a researcher with a PhD on spatial statistics from Sheffield. I mean, she's a very distinguished person, and we are delighted that she could join us as moderator today. So welcome, Thelma. Thank you very much for joining us.
Yes, thank you, Gilberto. It was very frustrating for me for not being able to join yesterday as a moderator, but here I am back today, and hopefully with my system working perfectly. So I welcome everybody to this second day of GEO-INPE webinar. I am absolutely sure that we are going to have stimulating and exciting presentations, and also looking forward for your questions. But anyway, before we start, let's do some housekeeping. So the first one you can see right there. Please indicate your name and your affiliation. Please go to the list of participants, click on your name and then rename so that we can have your name and affiliation. On the second bullet, please don't forget, post your questions in the chat box, and I will be picking up the questions, trying not to have questions that have already been answered being picked up, again, and they will be responded accordingly. We have a good time for the questions, and yesterday was exceptional. So many good questions coming. And this really provided this stimulating exchange of experiences, which I think this webinar is really trying to focus. It's really a learning process for everyone. And also, please, we are recording this webinar. It's going to be posted afterwards in the GEO portal. So I hope there is no problem with that. So let's see what we are going to do today. So let's recap very quickly what we have done yesterday. So for those of you that were there, it's just a recap. We had the webinar focused on the Brazil's Forest Monitoring Project, PRODES, which provides the official figures of the rate of deforestation for the legal Amazonia area. Obviously, it's been expanded. And also the Terra, which is the near real-time deforestation detection system, which is really, really instrumental to guide actions on the ground. And also a brief note on Terra Brasilis, the platform that hosts geographical data, including those from PRODES and the Terra, were also presented yesterday. So how are we advancing today? So we advanced today with 2 presentations as well. We are going to have the 2 presentations, and we are going to have, Q&A session of 30 minutes. Please don't forget, put your questions in the chat. And then we have a short break of 5 minutes, and then introduce the second presentation on Data Cube, Brazil Data Cube, following the same procedure of Q&A. And then we are going to have only my final remarks as moderator, and the closing remarks from Gilberto. So I'm going to introduce Lubia and also Danielle. For those of you who were in the webinar, already know Danielle and know it is already a common face here. But let's start with Lubia. Lubia is a researcher at INPE since 1997, and she has a doctorate in applied computing. Her main working interests include spatial databases, free and open source software for GIS, Geographic Information System, remote sensing, and also other geographical applications. She was head of the General Coordination of Earth Observation for the last 2 years, from 2018 to 2020. And before that, she was the head of the image processing division, for 4 years. So presently, she collaborates with the program for satellite monitoring of the Brazilian Amazon and the Brazil Data Cube project. So as I said, the next speaker in this presentation, Daniel. Is Daniel. Daniel, as I said, was already introduced yesterday. He's the technical manager of PRODES since 2019. He works on the detection and estimation of the annual rate of deforestation in the Brazilian Amazonia. He has a PhD in biodiversity, ecology, and forest sciences. And finally, John Philippe Knape is part of the technical group of INPE's forest monitoring projects. Terra class, PRODES, the Terra, since 2012. And he has a master's degree in environmental sciences from the Federal University of Pará. So having introduced the three presenters for the first presentation today, we're gonna advance the discussions from yesterday, including the Terra Amazon, which is a geographic information system that provides support for the classification of satellite imagery. It was developed by INPE, launched in 2005, but Terra Amazon continues to be updated and freely available, as Lubia, Daniel, and João Felipe will, much better than I, tell you all about. So with that, Lubia, I think you are starting this presentation. Thank you very much.
Thank you, Thelma, for the nice introduction. I would like to thank GEO and the GEO staff for organizing the webinars, and also all the audience for being with us today. Well, since 1988, we have improved the methodology we use in our monitoring systems. We have, for example, to include new sensors, to provide new products, and to improve the way that we disseminate our data. So we have also at INPE invested in the software tools that support these projects. As you can see in this slide, at the very beginning, we were doing the interpretation of over 200 Landsat images per year, just to do PRODES on a paper overlay. The resulting map has to be handled in a vector GIS, and then the deforestation rate was the only number that was made public. Well, later we moved it to a general purpose GIS, also developed by INPE, called the Spring. And then we start doing the digital PRODES. However, this general purpose GIS would not be so effective to handle all the data flux and the processing that was required to deal with such a large project, such as PRODES, for example. Yes, then we decided to develop a software tool that was specific to support this monitoring projects that we had. And we called it Terra Amazon because at the time we were developing a geographical library to build geographical applications called Terra Lib. Terra means earth in Portuguese, and then we came with the name Terra Amazon, which is very nice and very beautiful, I think. And this software package manages the complete flux of data process and user management required to produce land cover mapping data using the visual interpretation of mainly optical remote sense data. So as you can see in this slide, Terra Amazon is used for the produce, the Terra and Terra projects for all the biomes, not only for Amazon, but also for the other biomes too. Here you can have an idea of the annual volume of data only for prods in 1 year. It's over 200 Landsat scenes that has to be analyzed, more if you consider other satellites that we also use to detect deforestation. We have 18 contributors to the map production, over 43,000 polygons of deforestation, and not only the deforestation rate, but as well the maps, the images, and the analysis should be put online as soon as possible, as soon as the data is produced. So the first thing that distinguishes Terra Amazon from a general purpose GIS is that it is able to capture the singularity of each project. So it always starts with a project manager that will think of the methodology that is going to be used and will translate it in what we call a Terra Amazon project. There, the manager or managers will define the area of interest, the arbitrary, he or she can define a spatial partition that will be used to manage the working by the team, will generate, will define the classes that are being mapped in this project. For example, if it's produce, that's only deforestation or no deforestation. If it's Terra class, you have like 10 or 12 classes of land use. And also the interaction of this, the mapping that's being done with other ancillary vector data. For example, you want to have the data, for example, in the methodology for prods, we know that we don't map new deforestation increments over the mask of deforested previously, areas deforested in the previous years. So this is all defined in this concept of project in Terra Amazon, and it will be enforced along the way, along the work that's being done. As you can see, obviously, Terra Amazon can access the imagery from local files or from web servers, and then they will be available in the Terra Amazon interface as layers to be analyzed by the photo interpreters. The Terra Amazon offers a set of geographical algorithms and image processing algorithms so that you can deal with the image, have the main image processing algorithms such as contrast enhancement, linear spectrum mixture model. You can even do segmentation and classification. We have algorithms for cloud detection and other functions and analysis that will be available for all the users of Terra Amazon, including the managers, the auditors, and the interpreters. Next, the data, as we are talking about photo interpretation on the computer screen, the way to have a good data visualization is very important. So, for example, the interpreters have access not only to the image that they are analyzing at that moment, but they can also connect with another image. For example, you can see easily the image from this year and the image from the next year. Then it's going to have the explicit the change. It will help them to map the new deforestation polygons, or they can have different color compositions for the image that will enhance this or that characteristic, that will make it easy for them to interpret the data. So this is a typical working environment for the interpreters. They have their screens running Terra Amazon, sometimes double screens if they think that it's better. They have the key features to interpret the classes that they are looking for in this type of the image, and then they will do the mapping on the screen. Very important, it's the vector edition tools So the users, the interpreters in this case, they will have their working cell. They will select, they lock the working cell that they are working at that moment. And we'll use this very well developed vector edition tools, and they will delineate the polygons of deforestations with, as I said, you can snap and you can have a magic wand that will do a segmentation on this in a very specific area. They have the topological correction. And as I said, because of the rules that were defined during the project definition, for example, you have the instantaneous and automatic maintenance of the topology consistency and the compliance with this rule. In this very simple and didactical example, you can imagine that these red polygons were the deforestation mapped in the previous layer, and the interpreter is mapping an area here. He or she doesn't have to worry about going over these previously mapped polygons, because when it saves it to the database, automatically it will be intercepted with this previously mapped polygons, and the topology will be correct. As well, it will not, he or she doesn't have to worry about being outside the boundaries of the cell, the working cell that's working at the moment, because this system will split it in the boundaries of the cell. That makes it very easy. It facilitates the work of the digital interpretation on the screen and the vector edition on the screen. Well, all as we discussed it yesterday, PRODIS is a very, for example, in terms of PRODIS, it's a very conservative methodology. We try to make sure that what we say that's deforestation, it is deforestation. We have a very commitment to the data that we generate. So we are very committed to the auditing of the mappings that we do, and this auditing phase is also carried on Terra Amazon. The auditors, which are people more experienced in the mapping, and remote sensing experts with more senior and more experienced, they will audit all the polygons, and they can change the geometries, or they can annotate them with text, photos, image clips to identify mapping errors or difficulties. And also and it serves as a channel of communication between the team. They have a chat. Terra Amazon provides a chat box for the auditors to talk with the interpreters, and Terra Amazon supports this phase 2. Along the time, we developed like annexes or plugins for Terra Amazon to facilitate the work. One of them is the Terra Amazon Monitor, which is a web application that have access to the geographical database that's been working on projects, and it's used to monitor the progress of the production at user and team level. So managers can see how many of these cells have been interpreted, how many have been audited, which ones have been ready, and which ones should be audited or haven't started yet. And they don't have to be seated in front of the Terra Amazon Monitor. They can do it from a web browser, from the cell phone, and that helps to control the production of the data. And another thing that we have done, we have adapted recently, it's an offline version of Terra Amazon, where part of the database is extracted to the local computer, and that requires the access of the internet only necessary upload and download steps. As you can imagine, this has been wonderful in the times of the pandemic situation, because we are at home office. We cannot be at our offices at INPE. So even though we are in this situation more or less almost from March, all the production for the project 2019 went well. We are on time with all these projects. And so it's something that we are always adapting and improving in order to have our data delivered properly. Yes, I think that I will mention again that as Terra Amazon works with a geographical database, interoperable, we are using PostGIS in our case. The data can be easily exposed to web services, and we have our data dissemination portal, Terra Brasilis. And then what Terra Brasilis what you can see in Terra Brasilis is exactly a production version, a dissemination version of the production database that was generated by Terra Amazon. You don't have to do anything in between, in the middle. Next, I will just say that Terra Brasilis can show not only the maps, the specialized version, but one thing that is very useful is to have this ready to consume queries and charts and dynamic charts, that dashboards, for example, for the deforestation rate for produce, which is an annual data. But when you have the Terra data, is daily data, so the charts are a little different. You can select a period of time. You can select states or classes of the alerts. So this is very useful for public dissemination as well for media. The press in Brazil is always checking the Terra Brasilis for the latest data, so they don't have to call anybody and ask for a chart and everything. You have the official information in a transparent way. Well, so I see Terra Amazon as part of what I am calling here an open software ecosystem, because you have Terra Amazon here being used by different types of users and roles to generate the data, but the data is being maintained in an interoperable and open geographical database. As I said, we are using PostGIS in our case. You have access to the imagery in open formats as well, either through web services or local GeoTIFF files. And you have the Terra Brasilis, that is our main dissemination portal, but this can also be consumed by other geographical applications such as GIS, as QGIS or TerraView or web applications through the internet. So everything, it's interesting for me is this: it's an ecosystem. You need bits and pieces, but they are all open and according to open protocols that you can adapt and use for your work. Well, lately we have developed in co-design with IBAMA, which is our agents responsible for the fiscalization and to act in the in the field, a prototype of application that we are calling Forest Monitor, for one initiative that we are calling the Terra Intenso. Intenso in Portuguese means intense. With the help of the Brazil Data Cube team and project, we were able to develop in a very short period of time a web application based on the Amazon Web Services, because with Forest Monitor, we are offsetting one of the difficulties to have the projects, which is the access to the images. Since this cloud provider provide the buckets of free of images from Sentinel, from Cibers, from Landsat, and it's open access, we generate this application. This is a web application. It has the features to do the edition and consume these images directly from the cloud environment. But what is the idea behind that? the idea behind that is to use even more all the images available daily. So we are using data from Sentinel, from Amazon, and from CBERS, and they have better resolution and the spatial resolution and time resolution. So in 6 months of running this system in 7 priority areas, we saw that we not only issued more alerts, but we have issued alerts of areas, smaller areas. And that was very important for the fiscalization people to plan their actions and plan and have macro and micro strategies to work in the field. It's running in 7 priority areas only in Amazon because these have a cost, and also because the fiscalization people, fiscalization agency, they are more interested in having stopping deforestation in priority areas, because if they stop the deforestation in these priority areas, in the general, the rate of deforestation will be a lot smaller. You cannot handle all the polygons of deforestation, but if you go into the ones that are really hot spots, you will be you have a more successful result. So in this here you see this, the circle is because it's the area of the range of action from the helicopter, and those here in the squared ones are partnerships with the state of Pará in their environmental secretariat. Well, I think that I'm on time. My timer is that. I just would like to thank again GEO for this opportunity to talk about Terra Amazon. Please visit our webpage. And I also have to mention that Terra Amazon is also developed with support of Funcati, which is our support foundation from INPE along the years. And the latest version of Terra Amazon was created with support from a project that we had with the Amazon Fund. Thank you all, and I'll be happy to answer your questions if you have some. Thank you.
Thank you, Lubia. And more than thank you for the excellent presentation. I also want you to thank for the really 20 minutes target. So thank you very much for that. Just an acknowledgement, I see in the list of participants, many people that I know for many years. As Gilberto has mentioned, I'm very senior, but I mean, you know, Gilberto, yeah, with some limits, right? So provide me a range. So, but I know many people that is enrolled, registered for this webinar. So I would like really to give them my heartiest welcome, in addition to people from all over the world. It's just impressive to see how many people are interested to know what Brazil is doing. And well, I always say, you know, Brazil does not have a lack of data and information. But obviously, Brazil cannot enforce the action. What we can do is our best to really, you know, provide the policymakers, decision makers with the best we can in terms of information, so they to minimize the potential errors, which I think are minimal here. So we have already started with some questions, and which I now pass it on to you and your team, Lubia. And Sergio Milano from the University Federal of Pará is being actively, you know, sending us some questions. So he sent us 2, which I'm going to put together. And the first one he sent was, is there training for the use of these GIS, I mean, this software tool? That's his first question. But then let me aggregate. And then I think he loved so much the system that he asks, may I contribute to INPE's imagery interpretation? And
Okay.
finally,
Right.
is there any possibility to transfer this methodology to other countries that shares the Amazonian forest with Brazil? So that's the first question. Go on, Lulia.
Thank you, Thelma. Well, regarding the training course to use Terra Amazon, yes, we had as you probably know, we have INPE have the INPE Amazon Regional Center. And in this center, they were specializing in training. So they had offered a lot of training, including international training on the use of Terra Amazon and in remote sensing, GIS using, etc. This right now we have even a project called Capacity Tree, which was a series of courses about these themes. Right now, I think that Capacity Tree is on the hold a little for a while to finish but the material that was produced, it's available online, video aulas, tutorials, user support. So if you're interested in that, you can just drop me an email and I will point you to these resources. As for the helping with the image interpretation, I will let that to Danielle to answer later, because it's with Danielle and Claudio if they are open to external help in the front of photo interpretation. I cannot answer for them. And the third one is that if it can be transferred to other countries, I think that yes. For me, the more important thing is that you have a methodology and a goal with your project. For example, for us, we have our goals. In PRODES, we provide the annual increments of new deforestation. In the Terra, we provide alerts, daily alerts for the law enforcement people. In Terra class, we produce land use on the areas that were previously deforested. So if you start with your goals and your methodology, what's your public, for whom are you generating this data, and how is your team, for how long you intend to carry on with this project. And then Terra Amazon, it's a tool. It's a good tool. You will not pay for software to use it. And so I believe that you can, from our good experience, I think that it can be transferred to other countries and other groups. Yes. About the helping, Danielle, Claudio.
Yes, I unless Claudio wants to give or Danielle wants to give a very quick response to that, I think it's a yes or no. Binary answer.
Yeah, I would just say that sometimes we have selective process in our team to contract new interpreters, but you can send me an email to just to discuss. It's okay.
Okay, perfect. So there is a related question that I think Luby can be answered very quickly. It is from Armando Alanis from Mexico. As a matter of fact, he has 2 comments here. So he says, with regard to Terra Brasilis, and I think that other tools as well, do you provide training to general public and media people to use the tools to facilitate the access to information? And also, just to provide his second comment, Armando also asks if you can share the link of the organization providing the training.
Okay, thank you, Armando and Jaime. About Terra Brasilis, I have to say that we should, but we didn't. We didn't provide any specific training for people or for media people to work Terra Brasil. In the end, we are very receptive to people coming to us. So every day we have questions in our phones and our emails. how do we do that? How I interpreted this and this and that. And we try to our best to answer. Fortunately, we have mostly a very good relation with media people. We know the main journalists working with the environment theme. So along the years, we show them how to use Terra Brasilis, how to access the data. We provide frequent asked questions. We are present at conferences in Brazil and other events like Mundo Geo and this Brazilian Symposium of Remote Sensing. At these events, we always have talkings and have stands for people to come and to talk to us and learn that. But I would say that so far, regarding Terra Brasilis, besides some frequent asked questions and some videos and our user support, we haven't done yet any formal training for the general public or for the media people. The other one, I forgot which one was.
It was to provide the link to the training.
Okay. I think that João have provided in the chat box. Please have a look at it.
Okay, great. And if not there, please let us know again. So there is a question also, Lubia and your team, from Laurent Dourier from IRD. And he congratulates for the developments, says a very impressive open source processing solution for very minimal applications. But he goes over to say, do you have plan to have specific tools for biomass estimation? And can you process point cloud data, for instance, LiDAR?
Yes, thank you, Lohan. Well, Lohan, that's how it works with us at INPE. We have the scientists and their groups, and they are developing the methods. Initially, not for an operational point of view. They are developing the methodology, the algorithms, and they are using whatever tool they intend to do to build the knowledge. When they have a good algorithm, this is observed by the operational process, and lately, and also at the same time or in parallel, will be included in the operational tools that are being used. So regarding LiDAR data and biomass estimation, I know that our colleagues at INPE have very good experience. We have good scientists with that. Luisa Aragon is one of our lead scientists working with biomass estimation and using LiDAR point cloud data. But as this is not included in the projects that we're discussing here, it's not included also in Terra Amazon. But maybe Claudio can talk a little bit about that. Our intention to have, I don't know if you can, to have a more completely system, no, Claudio, that will also include the biomass estimation. And I'm sure that this will motivate us to bring these algorithms and these scientific developments that are being fostering in our researcher groups to the applications, to the software tools, because we are very committed to these open solutions. We are very much interested in open solutions and open software, and this is it. But I would ask Claudio to mention something about this system, with a complete system that goes through the biomass estimation, if he can.
Thank you, Lubin. For the short time, we have a plans with together Aragon to get a map of biomass, the map existing today, and make put the deforestation over the map of biomass to estimate the emission of carbon in each deforestation. With this, we can improve and offer for the society balance for every month, for every country of the Brazil. This is for the short time. And Aragon have plans with GEO-INPE and the other scientists to improve this map of biomass using LiDAR and using other initiatives.
Yes, thanks, Claudio. Yeah, it's interesting also to see the last national greenhouse gas inventory of Brazil, which is not out yet. You know, they normally from one inventory to the other, they update the biomass map for, in particular, Amazonia, for which we have more data. And the last one included, you know, LiDAR data as well. So I think it's a matter of us to perfect this. And also, I think this is evolving to be exactly as you say, you know, into a situation where this data from LiDAR is also incorporated. Yeah, there is a question here from Jaime Garbanzo Leon, who asks what technologies are running behind in the back end. Are you using a special language or library? I know that Karini was answered this on the chat, but it's possibly, Karini, you could say something, you know, openly in this conversation here, please. Is it okay, Lubia?
Oh yeah, no,
okay.
I can't. Because
you want to do, yeah. Do you want to do that and then Karini complements?
Yes.
Okay, so go ahead. Yeah.
Okay, so let me try to explain to you, Jaime. Terra Amazon is a desktop software. It's written in C++ because it is it's based on TerraLib, which is a library that we have written in C++ too. However, this desktop, it talks to a geographical database that uses all the open protocols, the OpenGIS, SFS, and etc. TerraLib is built, it's a customization of these open source tools for web mapping. So it uses GeoNetwork, as Karin said, it uses JavaScript, Node, and other packages. I would like to say that we have also people have taken this technology, because Terra Brazil is these two things. One is the concept of the portal where the data is disseminated, but it's also the software package that implements an instance of it. We will implement that portal, we will implement the web service, and etc. We had in the past, for example, people that took this software package and had and customized it and changed it a little bit to implement other geographical data dissemination portals. But I think that, as Karin said, is Java, JavaScript, etc. I don't remember all the pieces there. If Karin or Gilberto Ribeiro could complement that.
Yeah, Karini?
I think Lubia said everything. I think
yeah,
it's
okay.
Yeah.
Anyone from the team wants to say
again, if you want to know a little bit more, just drop us an email that we will be happy to answer.
Yes, okay. There is only one question left here in the chat. Please don't be shy. Populate the chat with your concerns. But Lubia, I'm going to leave the last questions, which is what is the future, for the last. But I myself have one question. So, and we have not talked about this, but I think it's a very simple one, because when Brazil talks about deforestation, it talks about clear-cut deforestation, right? So
yes.
Yeah, so
Prodis talks about clear-cut.
Yeah, so I personally think that it avoids. It makes it more accurate, because either you see it first or you don't see anything. So the clear-cut is basically that. However, when you think about some countries define forests in relation to some thresholds, like minimum area, minimal canopy density or canopy cover, and finally minimal height, and this might change from one country to the other. They have this flexibility. So if we consider these three parameters, right? So how would this impact in your vision all the processing? Is it only related to the additional, I would say, added complexity to the interpretation? How do we deal with height? Oops, I hope that's not a really too complicated question, but this is the real life.
Yeah. I think it's complicated for me that that I'm the computer scientist, not a remote sensing expert, but I think that it does add some complexity, and you will have to develop new methodologies and new algorithms. I think that we have a glimpse of that yesterday when Marcus Adami was showing the use of SAR data for degradation and the selective logging, for example.
Yeah.
But I think that it does add some complications. We will have to adapt our algorithms and the training that we do for our experts. But I'm afraid of giving the wrong answer here because I'm not a remote sensing expert. So okay. I would refer it again to Claudio and Danielle.
Yeah.
That should comment on that.
That's perfect. So anyone that wants to provide an answer to
Luisa
that
Aragon
from our team, Luisa Aragon, Claudio, we have some time. So please, and even Gilberto, if you want to say anything, please feel free to do so. Yeah, who goes first? Hands up. Who's gonna talk? Hands up. Claudio.
Claudio. A little bit.
And is Claudio going to be followed by anyone else?
Danielle.
Apparently not. Okay, please, just do this, then I can see you and I'll call you after that. Aragon, that's perfect. Thank you very much. Claudio, go ahead.
Okay. For the open vegetation, for instance, savannas or other open vegetation, it's more difficult to identify deforestation, Terra. Everybody know if you have more soil, more influence of the soil and the reflectance of the energy, it's more difficult to identify the deforestation or degradation in this time. But I believe it's possible improve some techniques to identify, for instance, if you use a LiDAR, you can have information about the higher of the vegetation, or you can improve segmentation to identify the canopy and identify the percentage of the coverture this canopy on the region. With this information, you can improve the classification, but the open formation, it's very more hard, the classification of this.
Thank you. And Aragon, do you want to complement?
Yeah, just very quickly, Thelma, thanks for opening the word for me. But yes, I think it's more or less on the line that Claudio said. I think it's very important that we use the new technology to define in a standardized way across the globe these parameters to evaluate the change in forest. And forest and other vegetation too. But we have data already. So there are like global maps of forest height, for example, canopy cover, and the area that we measure normally with remote sensing data. So combining these three variables that are nowadays available, and the tendency is to improve through time with JEDI and other initiatives, and even the biomass mission that can also bring some information on tree height. We'll be able to have a standardized global way to define our limits to measure deforestation in forest and other vegetation according to FAO parameters or countries' definitions. So this, I think, will be very, very, very nice, and we need to pursue this way. Okay, I think that's it. Thank you very much.
Thank you, Luis. How would I not give you the word you saved me yesterday? So thank you in public. Thank you. Anyone else from the team wants to complement? Or I think that is very sufficient. Thank you very much. We will go to Laurent Dourier has another question, and says the following: what are the key technical / algorithmic issues to map reforestation? Does Terra Amazon could be used or is used for such application? So we are moving from deforestation to reforestation.
Yes. Wow. Yes, there is the technical issues. I think that the reforestation is, as we were discussing previously, related to open forest and the height and everything. And we have been doing that in Terra class. In Terra class, we have a class called secondary vegetation, and the secondary vegetation is regrowth. No? Terra class is also uses Terra Amazon. But again, I should stress that Terra Amazon is the tool, right? The methodology should come first, and the training and the use of the image should come first. That's why we have to think about the project. And then I think that Terra Amazon can be used for this mapping too. As an example, we have the Terra class software with the Terra class project that has one class of regrowth and secondary vegetation.
Okay, thank you, Lubia. We have a question from OK Rosenquist. Hi, OK. It's so nice to have you here with us. Many thanks. And OK says that yesterday Gilberto explained that PRODES is focused on mapping clear-cut of pristine forests, also for political reasons. However, with the data in Terra Amazon, you sit on an incredibly unique data set where you can track the land cover history of the changed polygons several decades. The question is, are there any efforts to use this unique data for scientific purposes? And noted again, Gilberto, not for national reporting.
Well, I think that it has been used. If you look at the PRODES website, I've been collecting references, citations to PRODES data, and I know I have more than 1,000. And each year there's a number in different journals from different subjects and subject topics. And I think that it can be used, and it has been used for scientific work on this data. I think that one thing that we also discussed yesterday that we will do in some time, I don't know when and how much effort we have, that is the deaggregation of the deforestation data from previous to 1980, don't remember, Claudio. But when we joined it, it's not annually the maps from.
I don't understand.
Up to.
I have a little noise here. You can repeat, please?
No, I was saying that to answer this, we are using this data to track the land cover history of the changed polygons. But now we have one task that we have to do. I don't know when we will be able to do, is deaggregate the deforestation data from previously to a year that I don't remember which year. You mentioned yesterday.
To 2008, after 2008.
Yeah, before 2008.
We aggregate all deforestation before 2007, and we have a different annually data after 2008.
Yes.
Including.
And yes, Aki, the the annual polygons are available for public download at the Terra Brasilis website. You can download it in shapefile, an open format, and you can download it from there.
Perfect. Now we are running almost short of time, so I'm going to go to the question from Marcelo Vieira Greenberg, and he asks, what are the next steps? What is the roadmap? What are the challenges? And he also thanks everyone for sharing the knowledge.
Yes, the long question, no? Well, from my point of view, if you are talking about the monitoring systems, we do have some strategic planning that it's always dynamic we're doing. And it goes to expand the monitoring for all the biomes of Brazil, right, Claudio? And have the annual data for all the biomes, to have the historical series for the biomes. Also to have new versions and new additions of the Terra class project as well. In the Terra data, as I showed you, we wanted to have the alerts more up to date, more using data, decreasing the revisiting time, using in more higher resolution data. With that, we are exploring platforms to do that to consume this data, like the cloud platforms, as I showed you with the case of the Terra Intense. And also to have more automatization. I don't know if this is correct. Automatization in the data production, which relates to the next presentation about the BDC data cube, to have the maps to change it from the photo interpretation to audition and correction of the data that's generated automatically, in order to have the same level of accuracy that we have right now, because this has always been our driver. We cannot go back in the terms of accuracy that we have so far. We have always to maintain that level of accuracy, because this data is too important for our country, and INPE is it has this expectation of good quality data that we cannot go back, right? So I don't know if it made sense, but in general overview, in my view, this is the road and the challenges ahead. Thank you.
Thank you, Lube. So we ran out of time for this first session, which was extraordinary. And I please ask Lube or anyone from the team to please go and respond to Armando Alanis from the National Forestry Commission from Mexico. He wants to know who he could contact to know more about the platform. And there might be other questions over there. So, but anyway, okay. I am now being called to have a 5-minute break. So I'm gonna run to have my coffee and keep my energy for the second session. So thank you very much for all the questions. Thank you. And please don't miss the Brazil Data Cube. Oh my God. Thank you. So we are back. I have my coffee here, so to keep me running. Hope everybody had their own time to have their coffee as well. Sarah is just raising her coffee. Yeah, that's good. But Brazilians without coffee, forget. So we are going to start now our second presentation. So I want to introduce our second presentation, which is going to focus on Brazil Data Cube. And Dr. Karine Ferreira is the one who is going to provide this presentation to us with Gilberto Queiroz. And let me tell you a little bit about Karine. And Karine also works at INPE, has a PhD in applied computing, and she conducts research in geoinformatics with particular interest on representation, processing and analysis of spatial, temporal, and big Earth observation data. She is responsible for coordinating technological innovation projects such as TerraLib, Terra Brasilis, and Brazil Data Cube. And Gilberto Queiroz is a senior technologist at INPE and currently is one of Brazil's Data Cube project leader. His research interests include remote sensing applied to land use, land cover mapping, and also geospatial big data platforms. Okay, with this brief introduction, let me just quickly introduce Brazil Data Cube. It's a project that it's in development at INPE since January 2019 and aims at creating multidimensional data cubes ready for analysis using medium resolution Earth observation satellite data. So the project provides land use, land cover information about the entire Brazilian territory through machine learning and analysis of multi-temporal information. And obviously, Karine is gonna, give you this big presentation. And what stimulates most is that, INPE always looking ahead, always trying to be on the most innovative technologies to really improve environmental monitoring. So it's great to see this presentation and great to see how much technologies are allowing us to improve continuously. Karine, it's with you now.
Okay, thank you, Thelma, for the introduction. Good morning for everybody. First of all, I'd like to thank everybody for the opportunity to present our work here. So my name is Karine, I work here at INPE, and today I will present how we are building data cubes, analyze red data and data cubes here at INPE, and how we are producing land use and cover data from these data cubes using machine learning and big data technologies. Okay, the Brazil Data Cube project started in 2019, and in this project, INPE is producing analyzed red data or surface reflectance with plus information about cloud mask and quality assessment of the pixels. And we are creating analyzed red data of medium resolution satellite images such as Sivers 4, Landsat 8, and Sentinel-2. And from these analyzed red data, we are creating multi-dimensional data cubes. And I will explain how we are doing this here. And besides that, besides the data sets, we are developing and use a lot of big data technologies, machine learning methods, and image time series analysis to process and create the use and cover information in areas in Brazil. This is just an overview of the Brazil Data Cube project. As I said, before creating analyzed red data and data cubes that are available in the Data Cube portal in that link, we are developing and using neural network methods and deep learning and machine learning methods to classify satellite, the time series extracted from these data cubes. We are developing these methods in our package called SEEDS. That is a package that has a lot of algorithms and methods for deal with satellite image time series. And you can get this package here in this GitHub link. And this is the overview of the project. Then we can see two main motivations to develop this project here at INPE. The first one is to produce technological innovation to improve the environmental monitoring projects developed by INPE. As Luisa presented today, Terra Forest Monitor and the Terra Intenso are using the web services that we are producing here in the context of this project. So this is the main motivation of this project. And the second motivation is the potential of time series analysis and machine learning methods to produce land use and cover information from big data. In the literature, there are a lot of papers about this, showing the potential of these methods to produce land use and cover information. In this case, this picture can see a paper published by our team, Rolf Simões. So since you have good samples of land use and land cover, you can extract time series from data cubes. In this case, we use modes product. And this index, NDVI, EVI, NIR, and NIR, and produce maps for Mato Grosso state in Brazil, as you can see here. Here you can see the time series of modes product, and you use these samples in this time series to train the machine learning methods, in this case SVM, to produce this kind of maps. So how we are creating these data cubes? The first step, we are creating analyze red data. So we are getting the images from external providers such as USGS and ESA, and we are using the softwares provided by these external providers such as LESS, SRC, and C2Core to produce surface reflected image with information about mask, cloud, and quality assessment for each pixel. And from these analysis-ready image collections, we produce the data cubes. To create the data cubes here in this project, we define a hierarchical tile system using the Albers equal area projection, as you can see here. This tile system is composed of 3 different grids with tiles with different size. So we have the first one called BDC large, and which tile has 6 per 4 degrees. The second grid called BDC medium, and each tile has 3 per 2 degrees, and so on. So we developed these grids, and we are using these grids in Brazil to produce the data cubes. So the second step is, for each tile of this grid, we select the original images, the analysis red images that intersect this tile. And after that, we merge this image, we crop this image, considering this tile. And so we apply a temporal composing in a temporal step, for example, 1 month or 16 days, to group the pixels in one image. So in this time composite function, we select the best observation, the best pixel in this time. In this case here, in this example, in a month. So we compose these data cubes using the best observation in a certain time period. So as I said here, the time compositing, in this phase, in this step of the process, we are just using pixels, valid pixels, or that is pixels that are not cloud or not cloud shadow. So, and based on these valid observations, we have 3 different functions to combine these valid observations. So we can get the average, we can get the median of the valid pixels, or we can use the stack function. The stack function sort the pixels based on the quality assessment of each pixels and get the pixel with the best value. To create the data cubes, we are developing a lot open source Python scripts, and based on this script, we are developing a web application with graphical interface to produce these data cubes. So this application called Data Cube Builder, BDC Data Cube Builder, we have 2 versions of this application. One version that is running here in our INPE infrastructure, in our internal computer network, and another one that we are using to create Sentinel-2 data cubes in the Amazon Web Service cloud computing using Lambda services. This picture are prints of the Brazil DataCube portal. You can see the tiles that we have covered the entire Brazilian region. So we can see the green tiles represent tiles that we have ready data cubes to be downloaded, to be processed. So here we have the first picture, we have the Cibers 4 WFE data cubes. The second one, we have this Landsat 8 data cubes, and the third one is Sentinel-2 data cubes. And these data cubes can be downloaded and can be processed using our technologies that I will present more. So, as I said, we are creating, producing data cubes for each tile of this grid. So for each tile, we have a lot of files associated to this tile. So we have this, we are producing this tile using the COG format, Cloud Optimized GeoTIFF, and we have one file to represent each spectral band from the original images, one file for each spectral index, EVI and NDVI, one file for cloud mask, one file for the valid number of valid observations, one file for data provenance, and so on. So for each tile, we have a lot of files associated to this region. In the DataCube project, besides the data cubes, the analysis of data and data cubes, we are developing a lot of web services that are used to search, to process the data that we are producing. And we are also developing a lot of applications with graphical interface to access these data sets, as you can see here in this image. The image collections, the data cubes method that we are creating here in the Brazil DataCube project are disseminated in compliance with the STAC, Spatial Temporal Asset Catalog Specification. And we are developing a web services to serve these, to disseminate these data sets through a web service. And we are also using and providing OGC standard web services to access these data sets. This is an example of other web services that we are producing here, that develop here in the Brazil DataCube project. Here, a user can give a period and location, and the service can extract a time series associated to this spatial location and period. This is an example of other web services that we are developing here, the Web Land Trajectory Services. In this service, we are organize a lot of land use and cover data sets, such as Terra class, PRODS, and Terra. And you can extract the trajectory of a location considering these data sets. In this example, for example, we have here land trajectory of a location that was detected as forest in 2012. After that, this location was identified as deforestation alerts. After that, this location was classified as deforestation by PRODS, and so on. So we are developing this web service is very useful for us to validate the maps and to extract samples from these land use and cover data sets. This is the portal, the link of the portal. So we have the portal of the project, the Brazil DataCube portal. Here we can see the data sets, the data cubes, collections, and classification data that we are producing. We are also providing Jupyter notebooks for users to process this big volume of data in our internal computer network here at INPE. And we are also developing the seeds, as I said, and an integration with the Open DataCube platform. Just shortly about the integration with the Open DataCube platform, we develop a lot of Python, a set of Python scripts So this script can read the metadata of Brazil DataCube datasets, use stack, and put this metadata in the ODC internal PostgreSQL database. So using this integration, you can use the Jupyter notebooks, the ODC Explorer, and the ODC web service provided by the Open DataCube platform. This is an overview of how we are producing land use and cover maps from these data cubes. So we extract time series from these data cubes, and we are using deep learning and machine learning to process and to classify these time series, to test the methodology. So to test our methodology, you classify 3 data cubes. So here we classify these 3 data cubes for this area in Brazil, in Cerrado biome in Brazil. So we classify the Sentinel-4, Cibers 4, Sentinel-2, ELETSAT-8 data cubes in this period. This is the sample that we use to classify these data cubes. So here you have the time series associated to natural vegetation, the time series associated to agriculture, and the time series associated to the pasture class that we use to train the machine learning classifier to produce the maps. Yes. So now we have the results. Here we have the maps created from these data cubes using these samples that I showed. So in this case, we use the this vegetation index and the deep learning classifier multi-layer perceptron with 5 layers, and using the CITSAR package, and we use the prod Cerrado in 2019 to validate this data. And we produce the data with a good accuracy. Next. So for more information about the Brazil DataCube project, we have a paper that we published 2 months ago about the methodology, about all the products and web services and data sets that we are producing and the classification results. And we have the site of the project that we have a lot of information about the GitHub, when you can get all the open source software tools that we are developing here, and news and publications about the projects. Next. So to do this, we are using the Amazon Web Services. We won a credit from GEO and AWS Cloud Credit Program of $60,000, and we are using this credit to process in 2 fronts, to create Sentinel-2 data sets directly in Amazon Web Services from the synergized S3 bucket. And we are using this credit to classify land use and cover maps from the Brazil DataCube data cubes. Next. So he just a comment about that we using Amazon Web Service Lambda, we have using this type of service is much faster than using a premise hardware here at INPE. So we are use this credit in the Amazon Web Service specifically using Lambda service to produce the Sentinel-2 for all Brazil. So as final remarks, we want to submit the BDC data cubes to the SEALS analyze red data for land compliance. SEALS define or requires a lot of metadata about the data, provenance and cloud mass, and we have this in these data cubes too. So we will submit it to SEALS to get this compliance. We intend to create analyze red data and data cubes of Sentinel-1 images too. We are working in the harmonization and mixing of Sentinel-2 and ELETSAT-8 satellite images to create mixing data cubes. We would like to promote the use of data cubes and time series analysis to extract different kinds of information, not only land use and cover information, but other kinds of information here in Brazil through workshops and tutorials. And we intend to apply the BDC methodology and technology to other countries, for example, Mozambique. This is a pilot project in Mozambique that we start this year. The main idea is to apply the BDC methodology and technology that I presented here to create Landsat data cubes for Mozambique and produce land use cover data from these data cubes. So to do this, we are using Landsat 5, 7, and 8. So we have to harmonize these data sets. And we use the IPCC classes and this samples provided by CFRN, just to show that we started to create one tile of Mozambique here in the Brazil Data Cube project, harmonizing these Landsat 5, 7, and 8, and we developed it and we are validating this data cube. And now we will get the samples and we will start to run this pilot for one tile of Mozambique to test the methodology before apply for the entire country. Thank you. We have an excellent team here behind the scenes, and I would like to thank everybody. This team is provided by INPE researchers and software developers. Next please. And PhD and master students. And that's, thank you. Sorry for the thank you, everybody.
Okay, Karine. Thank you very much. Excellent presentation. And it really shows, you know, the efforts and how much can be achieved with a very small team that INPE has. So it's just incredible. We have already some interesting questions, and I'm gonna put two of them basically together because I think they address similar issues. One from Ileana Aldrete Leal from the National Forestry Commission from Mexico. Thanks very much for the Forestry Commission from Mexico to be so actively engaging with questions in the chat. And it says the following: when you build the tiles, have you had the problem that there are no cloud-free images throughout 1 month? And perhaps in the most rainy season? If so, how have you addressed this issue?
Yes.
And then I will couple this with the question from René Bouclé, sorry if I'm not spelling your name correctly, from JRC, you know, great institution also, great friends from us. And René has a question related to cloud and haze. And his question is, how do you handle the recurrent problem of haze when deciding on the best monthly pixel? And he continues saying, I assume that haze will not be filtered out by your cloud mask.
Yes, I try to remember the questions. So yes, there are some periods that you don't have a valid observation for this period. For example, 16 days when you use the Sentinel and we are in a rainy season. In this case, we put our no data in the data cube value in this timestamp, so the user can decide how they want to manage it. If you want to apply interpolation and what they want to do. So yes, and so in this case, the second question about
haze, about haze. You know, he says that possibly haze is not filtered out by the software. So how do you deal with haze?
Sorry, I can't understand.
It is not cloud. It's not cloud. It's haze. Haze, H-A-Z-E.
Can I help? Can
Yes,
help?
please, Gilberto.
Okay, haze normally refers to the aerosols available in the image, and therefore you would need to fully take the haze to have a very good atmospheric transfer program that would estimate the haze and remove it. And at this point, we're not doing it for Brazil. But of course, that's not, if we consider that this is a major problem, then we do it. You have to remember that most of the use that we're doing for land use and land cover actually uses time series. And time series and the standard product is a 16-day product. So overall, a year, for example, of work, a 16-day product, you would interpolate the pixels which are problematic, and that would reduce the impact of hazy data. That does not remove, and in the long term, you are completely right. It would be important to have very good atmospheric transfer algorithms to reduce the haze in the images.
Thank you.
Okay,
I don't know if Gilberto and Renan can add something.
Yes, so the stack temporal composition we are using, it's only based on our cloud masks. So at this step, we are not using any haze mask. We trust our atmosphere correction algorithms.
Okay, we have lots of questions. So thank you very much for everyone that is really interested in this topic. Let's go. Okay, Rosenquist has said the following. Karim, you mentioned that you have cubes for Sieverts, Landsat, and I think, which I think he thinks correctly, but Sentinel-2. Are the 3 cubes in the same grid system so that the data sorts can be used interoperatively? That is analyzed together?
Yes, they
and
are.
Then his second question, just to not, Are there any plans to include SAR data in the cube? Sentinel-1 and ALUS scan SAR or public open global mosaics? And this is also the question from Sergio Molano from the Federal University of Pará, of using SAR data, radar data, such as Sentinel-1.
The first question, we are using a grid for each satellite image. We are using a grid for the Sieverts 4, another one for Landsat 8, and another one to Sentinel-2. But these grids follow a hierarchical tile system, so you can for one tile of the big tile system grid, we can get 4 for the middle grid system. So we are doing this because of the size of the files. We want to maintain the manageable size of files, because considering the spatial resolution of these images. But you can use, you can use these data cubes in an interactive way, together. The second question is about, sorry.
Are there any plans to include SAR data?
Yes, we in the original data cube project, we don't have this task. We are focused on optical, Sentinel-2, Sieverts 4, and Landsat 8. But we intend to include SAR data. We intend to start doing it this year, together with Claudio and the PRODS team that have someone working on it. And we will start doing this year.
Okay, thank you, Karine. Let me go to a question that comes from Indonesia, from the Minister of Environment and Forest, I guess. Ana Tosiani. She asks, what is the purpose for dividing the grid tile into 3 shapes? Do they have a specific purpose for every grid tile? Which is the best grid that is appropriate for forest monitoring in Brazil?
The main reason to create this tile system is first of all, the size of the files that I said here, because you have to have different grids, grids with different tile size. So you can manage these files in our computer and easily. So we are using this projector, and we are based on the tile system defined by IBGE, I don't know how to say in English this. So I think it's, I don't know if someone want to add something about the grid system. I don't know, Claudio, if you want to say more about this grid for deforestation monitoring.
In fact, Lubia, you can talk, please.
Well, if I may complement something, as Karine mentioned, the thing is that the grids are interoperable because they are hierarchical, and they are mainly used to manage the file size if you're downloading or if you're processing. So you have to take in account the extension of the area that you are monitoring and the data that you are monitoring, the imagery that you are using. This is, if you are going to use, for example, if you are going to monitor the entire Amazon legal area using CBER's data, then it's easy to have the larger grid. But if you are going to use Sentinel data, then if you will have to manage several files, if you're going to download and process it locally, then you use the smaller grid. But in my opinion, there's no such a thing as the most appropriate grid for forest monitoring. It is related to the data set, the images, the spatial resolution and the sensors that you're going to use, and the extension of the area that you are going to monitor. In my opinion, is this.
Okay, thank you. We have so many questions coming in. I'm impressed. Claudinho, I saw you shaking positively. Great. That's great body language. I have a question here from Frank Martin Seifert from ESA. And his question is the following. Why are we forcing Sentinel-2 in the BDC in a 16 days regime? The revisit of the Sentinel-2 system is 5 days. Okay. And forcing it into the Landsat revisit 16 days will lose information.
No, it's a good point. Thank you for the question, because I present here the time composite, but we have the identity data cubes in the project. So these identity data cubes, we are not applying the temporal compositing function. So in this case, in these identity data cubes, you can see in the picture, you create Sentinel-2 using 5 days the temporal of the Sentinel-2, the temporal resolution of Sentinel-2. So in this case, you have some parts of the grids that you don't have information, but we provide these data cubes called identity data cubes for the users. So a user can decide if they have to apply a time compositing or compositing, use a month or 16 days, or if they want to use the identity data cubes, you get the data cubes without temporal composition. So we are providing these identity data cubes for the users too, not only the temporal compositing data cubes. It's an important point. Okay, Hannah, can you?
Yeah, thank you very much, Karen, for the, who is answering as well? Is anyone?
Yes, so
yes, sorry, Hanan, yes, please.
So when we are using the identity data cube, we use the data on the same date it was acquired. And when we are using it with a time composition function, we do what we call also a regular data cube. So for algorithms that use time series, many of them can't handle a irregular time series, which is provided by our identity data cubes. So even if Sentinel has a 5-day revisit period, there are some areas where we have an overlap of adjacent orbital images. So the regular data cubes provide a regular in time series, which is better handled by the time series algorithms.
Thanks, Hannah. Anyone else, or can we move? Lubia, you want to say something? No? Just, you know, when you want to say something, Lubia, I see you're eager to participate here. Please. Lubia?
No, I'm not. I'm saying that
okay.
The answer, Renan provided a very good answer.
Perfect. Yeah. So good. So let me go to the next question, which comes from Mulitin Milenkovic. Do you have any plans to expose your data cubes publicly, e.g. by using OpenEO API?
Using OpenEO, yes, we are, the data cubes are open. All the data sets and all the software that we are producing are open. So, and we can connect with Open the EO, let me, the name is Open, Thelma, the
API, OpenEO, I think is the Earth observation
open,
API.
It's an R package that called OpenEO, I think it is. So this package, we are developing a lot of tools to connect our data cubes. So we developed an R package called RStack. So this R package can read the metadata and data cubes following the stack metadata, the stack metadata standard. So using this RStack, people can read the data cubes from the Brazil Data Cube project and process these data cubes using the OpenEO R package.
Okay, thanks, Karin. Anyone else is fine? I don't see any hands up. Perfect. So I'm gonna go to another question from Laurent Duguet from IRD. How difficult is it to reproduce the BDC in other countries? How much time will it take for Mozambique, for example?
Okay. We will develop this pilot for Mozambique in 6 months. And because we have a very experienced team here in BDC, so we will run this project in 6 months with our team. So yes, you can apply this technology. We are developing a lot of open source and open application that can be used for other countries. The main challenge is the data sets. So the internal computational infrastructure that you will use to process this. In the case of Mozambique, we will use the AWS we will get the images from Google Earth Engine. We will get the images from Google Earth Engine. We will put this image in the AWS and we will process the data cubes on AWS because we have the credit from GEO. Thank you, Gilberto. Thank you, GEO, for this. So we will do this using this credit. So I think it's the main challenge where the country will process the data sets because it normally is a huge volume of images, satellite image. So we have to use some cloud computing or the country have to do a computational infrastructure to process this. We are using, just about this, we are using the AWS, but we are building an infrastructure here at INPE too. because we cannot only use AWS. So the idea is to process the data there more faster than you can, and then put the data here in our internal infrastructure here at INPE. So I think the main challenge is it nowadays.
Okay, Gilberto, I think you also want to complement, and Claudio? Gilberto?
Yes.
Claudio, please, please go ahead.
Okay.
I believe another big challenge is get a good sample to classify the data. We have two challenges. One challenge is building the data, the big data, put the information available for training for the others. The other challenge is get good sample to make analysis about the forest or agriculture or pasture of the region. This is the 2 points you need. You need provide the two informations. You need to provide data, and you need to provide good sample to get a good result on the end of the process.
Yes, Claudio. Yes, good point. It's a challenge.
I think the question for Laurent goes deeper. It's more or less the following: what should be the philosophy of data cubes for big regions? We know that some countries, like Brazil, have managed to have a very good team that is able to develop a data cube for its country. That is not the situation everywhere. The other point is, if you develop a data cube, where should you host your data? In the case of Brazil, the data is hosted locally in a server that sits in Brazil, managed by the Brazilians. So an Amazon Web Service is only used as the initial processing step. Now, and that also gives Brazil the possibility of not charging anyone who uses the data, and also the survivability of not having to have an agreement with Amazon. So this is a debate. The position from the GEO Secretariat is, of course, welcoming solutions. We like the Brazilian proposition because it's completely independent of the big players like Amazon or Google or Microsoft. And of course, we hope that the GEO community would have a debate. My dream, obviously, is that the Brazilian data cube or a similar model, which is independent of the big players, would be available everywhere for the globe, and we don't need to replicate it in each country. We just need enough resources to have one big data cube for the Americas, another one for Africa, another one for Asia, Oceania, or another one for East Asia and South Asia. So this is a very important debate, which is still open, and we hope that all of you can contribute to it.
Okay, so our time is coming to an end, but I could not go without really addressing one question that comes from Antonio Carlos Sanchez from the Ministry of the Environment of Brazil. So I really welcome and appreciate the participation of the Ministry of the Environment of Brazil in this discussion. So this is the last question that we will be addressing. And the question is as follows. Do you consider developing a new product, perhaps AI-based, that could support annual monitoring associated with Brazilian forest law? Second, it would be very useful to have annual maps with enhanced spatial resolution, for instance, Sentinel, delivered in a timely manner to support state-level environmental agencies in monitoring rural environmental registry requirements and compliance mechanisms. And he gives as an example the legal reserve quotas that are in the Forest Code of Brazil. So that's the question from Antonio Carlos Sanchez. I thank you very much for the question. And I am absolutely sure that we have a beautiful answer to your questions. Thank you.
Okay, for the first question, thank you for the question. For the second question, I will ask Luisa to talk a little about the Sentinel Hub, about Sentinel-2 here, that we intend to use in the Brazil DataCube project. But regarding the first question, we have initiatives here at INPE with Claudio and Eymar to connect data cubes and time series with Terra NA, and to use this platform called Terra NA that we are developing here at INPE in this context of forest law. Claudio, I don't know if you can say something more about this, but we have some projects submitted about this, and we will integrate the time series and data cubes in these projects. And I don't know if Claudio wants to add something, and I would like to ask Luisa to talk about the Sentinel Hub, because it's an important initiative for us here in the context of the Brazil DataCube project and for Brazil as the whole.
Yes, the Sentinel Hub, it's the result of an agreement between Brazil and the ministry and the space agents with the European Union. We are building, we are prototyping already, we have prototyped already this first, the system that we will synchronize the Sentinel data from Brazil here for the local community. As we are using the INPE infrastructure, because in the agreement, INPE is the organization responsible for do that, the data will be here already in our infrastructure, and then the people from the Brazil DataCube did. It's the first beneficiary because they will be able to have the data cubes built in synchronization with the data being generated. One thing that that occurred to me that to say now is that the data cubes, they never end, because the data is being constantly, new images are being constantly generated. If you want to talk about time series, it never ends. It's an open, the series, it's always being augmented with new data from images and etc. So I think that, Antonio, we have all the bits and pieces to make the system and to deliver the data in a timely manner as you asked. And we just, we also have the knowledge, and we intend to collaborate with other agencies to create the best product, the specific product to specific users. And that goes to your question about using the car and using the quotas. And I think that I can say that INPE is able to develop the systems that the ministry needs to respond to these demands with the car.
Okay, thank you, Luis. I saw that you want also to compliment Luis, Aragon.
Yes, please. Thank you, Thelma. I think this is a very important question because it takes to the next step of the use of this data in a more, let's say, customized way. Karine talked about Terra MA, that is this interface that gathers INPE data and other data that are available and allowed the integration of this data with from multiple sources, like deforestation maps with CAR, with the protected areas. And then there are already initiatives using this interface in Mato Grosso State. That is a customized system for law enforcement for the public ministry. that is using it. And there is another initiative in collaboration with CEMADEN, which is the Disaster Center from the Ministry of Science and Technology, using the same interface, but applying these customized features to the map region, Madre de Dios, Acre, and Pando. So we are already developing tools to support not only local governments, but also local governments from other countries. And I think this is the way to go forward, decentralizing the information and allowing the states to demand features that are specific for their applications. So these already exist. We can improve it in a way that we can disseminate more this type of technology. And I think this is the way forward. And in terms of artificial intelligence, I would say that this is just the means to get to the final result. You can get final results using several methods. And artificial intelligence is one of them that can be used, and people are already using to get some of the variables that we need to integrate into the system. So I think that's it that I would say to complement the previous answers.
Okay, thank you very much for everybody. So unfortunately, there is no more time for questions, but this has been so exciting and stimulating. You know, it is absolutely overwhelming. I think we should have more of these opportunities in webinars to clarify. So I have my final remarks to make. And I think I'm going to start with a remark that is as follows. INPE has always had its doors open for anyone that wants to see what we are doing, what we can do, and what are our limitations and potential. It's incredible that INPE does all these in such with such a small group and with such a small budget. So it's absolutely incredible. I have been a former researcher at Earth observation for 37 years, and then left in 2019. Had so many experiences in the Ministry of the Environment, as Gilberto has mentioned. The last one was as director of the Department on Policies to Combat and Prevent Deforestation in Amazonia and Cerrado. And I could see, you know, how much the data from INPE is helpful, not only to the federal government, but government at state level, municipality level. So data, the key issue is data is free. Data are absolutely free. So so I would say, I think I can do that, possibly on behalf of INPE and Earth observation, that I invite everyone, and in particular the Minister of the Environment of Brazil, who are so close to us, to come and visit us, sit down with us. And I think that we can respond much more to your questions than we have been able to do in this limited time here. But please, the doors are open. Maybe INPE can deliver much more than you see on the everyday media. So coming to INPE is gonna really, really be a good experience, both sides. But with that, I extend to everyone in any one country that is participating in this webinar, please come. We have so many visitors. And in particular, very much concerned about, can we expand this experience elsewhere outside Brazil and under different conditions than Brazil has, as we mentioned on the definition of deforestation being different in different countries. How can we handle this? So capacity building is one of the targets that we have to make this as open as possible. But let me, I think we have had two extraordinary presentations, building up from yesterday, from PRODES, from the Terra Intense that now uses radar imagery as well. Sentinel is available, but Sentinel is good, but Sentinel is recent. So can we build a consistent time series as is being developed for Mozambique, for instance, from 1990 to 2019, you know, using data that is available, satellite imagery? Well, I would say Sentinel was not there. So if you want to build, obviously Sentinel is useful. It can help us in the classification, but it's recent. So my question is, can we build a consistent time series that does not change methodologies, does not change the parameters that you need to ensure that what you are saying in terms of rate of deforestation or rate of reforestation or degradation is consistently addressed and maintained throughout time? When I say this is not a preciosism. This is not to say this is a pearl, this is a jewel. No. International requirements for REDD+, for instance, for the forest financial incentives, for reducing deforestation, emissions from deforestation, reducing emissions from forest degradation, you know, in else, enhancement of carbon stocks, conservation of carbon stocks. So we need to be sure that we are providing data consistently through time, and more than that, verifiable. And what do we mean by verifiable? Verifiable means, and some people used to say in the international negotiations, sorry to divert a little bit, but I think it's important to touch these issues. Some people used to say, well, we need to send some international auditors to look at project results or the Terra or whatever. And Brazil used to say very strongly, no, we don't want 6-7 people going there. We want the world to be able to check themselves with all the images, all the classification, all the data, all the analysis. We want to be questioned if they think we are not wrong. INPE has been questioned before. Fortunately, always won any queries that was done in the past. But by verification, I mean exactly this: being transparent, open, and we don't have anything to hide. Is it possible to do this if we change methodology, if we change whoever is doing this? Well, I doubt, honest, I doubt. I think that, you know, this is I think that there are decisions that need to be taken that ensure consistency and sustainability through time. So if Brazil has the longest time series of the rate of deforestation, yesterday Claudio addressed this. There were several questions. Why do we do 6.65 hectares? Well, by the way, Mexico does 50 hectares, but it doesn't matter. They do it consistently. But, you know, it has a reason. It has a why. And sometimes people just say, oh, I don't like this, but they don't try to understand why behind that question. So now going back, I was of the time, and Gilberto started saying, you know, that I am a senior. Yeah, it is senior Gilberto, going to be 70 next month, by the way. So it's senior. So I was able to, for 37 years, follow up INPE's developments from the analogical process, doing it in paper. This is in the museum now, but it's available. Everybody can go and check. They were audited, but very difficult. So I was at the time, you know, when I remember clearly when someone stepped in my door and said, we are bringing you a proposal. And I said, what? We are bringing you a proposal to do digital products. And I almost panicked. I almost dropped from my chair and I said, you gotta be kidding. And then I said, how are we going to maintain the consistency of the time series? Well, it was not easy because we had to recover the analogical data that were in all those overlays, 230 so many overlays that were carefully, treated so that we could have, every polygon in one overlay being matched with the overlay next to it. Took a long, long time. It was the best thing ever. So I always say, don't fall from your seat when someone comes with innovative proposals. We tend to be conservative. But innovation also has limits. We have to address innovation, time of delivery, the resources you have, only, financial resources, staff resources. So it's great, everybody wants to be very ambitious. But are they being ambitious to ask us for things, but still wanting us to do all the things without putting a bit of money or help us to have people to help us do it? That's the big question. I think that INPE does not have limits. It has an extraordinary team, but you cannot do everything with 6, experts, and having to rely on students and which is, some people don't say, oh, this is being done by students. What else? Give us, better conditions to do these things. Sorry for saying that, but I'm talking about reality. That is not only in Brazil, there's realities elsewhere. So how to cope with, Mozambique is one example. You have 4 people to do a time series, consistent time series from 1990 to 2019. Not only looking at forest, but you're looking at all the land use categories that IPCC suggests, let's say, in its guidelines, like, cropland, grassland, wetland, settlements, overland. So it is not only looking at deforestation, but looking at these tools that have been presented also to support innovative experiences as well, for instance, for support to the national greenhouse gas inventory in terms of activity data. Biomass is something else that we discussed in this presentation as well. So that was Karine, is when she was presenting DataCube. I think it brings exactly this. We are running out of focusing only on forest, but we are looking at how helpful we can be, in identifying land use change. This is really a challenge. This is really a challenge for any one country to do. So I think we are going in the right direction. I think that if I could, I would have stayed at INPE until I couldn't do anything else. My father used to say, I want only to stop working when I cannot walk anymore. So I think that he tried to do that as much as possible. So if I could, I would have been at INPE until today. But anyway, this is another story. But I just want to congratulate INPE for challenging itself. This is the way I put it. INPE challenges itself every day, every single day. And these 2 days webinar has demonstrated this. It's not to show to the world, but it's to say we are trying to improve. We are trying our best. So having said that, I just want to thank everyone, and just say that also it's important to say that INPE is not in isolation. GEO is providing a good support to INPE as well, and work is being done also with the Global Forest Observation Initiative, the GFOI. We are also going to develop work with on DataCube with CEPAL. And one issue that we are exploring seriously, and included also in the terms of reference for Mozambique, is uncertainty. This is challenging. This is a real challenge. Don't think that this is easy. But anyway, we are trying to really advance and show the limits and the potential of what we can do. And so I think that this is an extraordinary opportunity, not only to show what Brazil is doing. I don't think that this was really the meaning of this this webinar. I think it was just to have the amount of questions that we did, you know, clarifications. People are eager to know why you don't do this, why you don't do that. And this was a great opportunity, great opportunity. And so, Geo, I would sincerely thank you for the opportunity for allowing me to moderate this session. And I hope that with all this number of participants from all over the world, we can really have more webinars, more frequent. Maybe we can bring experiences from other countries as well. So, I mean, I think that this is an extraordinary experiment for sharing experiences and also how can we help each other? It's helping each other. It's not Brazil. We are all together. The problems are all the same, in particular developing countries. We know the issues. We are together. So with that, thank you very much for the opportunity to be here. Sorry for talking so much, but it's really the expression of my deep thanking to Geo for providing this and the opportunity to see you all here, you know, I can see your faces. And my biggest heart, I don't know how to do this very nicely, but anyway, my deep heart with every one of you opens door for INPE. Come. Thank you very much, Gilberto. I think now I have to send the word for you, excusing myself again for possibly not addressing the two presentations, but addressing the importance of these presentations and the innovative initiatives. Thank you.
Okay. Thank you, Thelma. Thank you, Karine. Thank you, Lubia. And I think everybody loves your passion for things. I can only, in the name of Geo, thank all of the attendance. It's been fantastic. A lot of very important contributions from many of you. Your presence here has been wonderful. We have had a record attendance, lots of questions, lots of discussion. So thank you so much. And please feel free to contact the Geo Secretariat or the INPE team. I would like to again to stress the enormous thanks from myself to Sarah Venturini and Rick Byans, which are really making this infrastructure and pulling making everything work as well as it did. You're most welcome. Have a good evening for those who are evening, good morning, and please keep in touch and contact us because this is just one step from Geo reaching you. You're the reason Geo exists. Thank you so much, Thelma, Sarah, Lubia, Karine, Rick, everybody. Thumbs up. Bye-bye.
Bye-bye.
Bye.
Thank you. Bye-bye. Thank you.
Bye-bye.
Bye-bye, everybody.
Bye.